is. Sorry, do I have to hit the record, Sarah?
You're recording.
Oh, sorry, it is recording. Okay, right. Yeah, thanks. Sorry about that. Right, so I'll hand you over to John, who's going to start off the presentation.
You're just going to advance the slides for me.
Yeah.
Right. Afternoon/evening, everyone. My name's Jon Hayes. I work with Les, worked with Atkins for 25 years now. I'm an engineering manager and I'm the CEM for design for Crewe Basford Hall Independent Lines Re-Signalling for CRSA. So the first thing I want to do is just give a bit of project overview and context. So Crewe, very brief history. So the Grand Junction Railway was constructed and completed in 1837, which runs north to south on that map that you can see on the slide there. There was a station built at Crewe in 1837 at the same time as the line opened, which was a very small affair at the time, a couple of small platforms. The locomotive works then opened in 1842, relocating from Edge Hill in Liverpool. In 1846, the London North Western Railway formed and additional lines started to be opened with Crewe as a major junction, as a kind of geographical intersection of 6 lines, as you can see on the plan. Relevant to this presentation and our project, the independent lines opened in 1901, what was called the Big Dig, which is the photograph you can see bottom right there. So that was freight avoiding lines because the station was already getting too congested with passenger and freight traffic. So they constructed the independent lines to bypass the station, had to run at low level to get underneath the junction at the north end in tunnels. And as part of that construction, they constructed Basford Hall marshalling yard a little bit further to the south, which is where trains were marshalled and shunted around to form trains carrying freight everywhere around the country. Next slide, please, Les. Just a couple of photos to show what Basford Hall looks like then and now. So this is 1985. This is during the remodelling of the station area. You can see the works on the left there. That was the infilling of the old knotty cutting, which used to take the line to Stafford. Or join the Stafford lines under the West Coast Main Line. Very dark and gloomy and dirty railway there. Move on to the next one, Les. And this is 2020, looks a bit cleaner and nicer. This is a nice route view image that shows the whole railway for a good couple of miles there. So, yeah, you can see the marshalling yard in the middle. Then the independent lines come off Basford Hall Junction at the top of the photo. The West Coast Main Line runs on the left, and then the independent lines run kind of around each side of the marshalling yard, and then join back together at the top end at SS North, and then go on to Crewe North Junction. Next slide, Les. So Crewe Beale Re-Signalling Project, what is it? So B-Hill stands for Basford Hall and Independent Lines. The full project title being the Crewe South, Basford Hall Independent Lines Re-Signalling and Recontrol. So the remit was to renew life-expired signalling equipment, signalling equipment dated from the 1950s, 1960s. Can I just the view on that? Nothing we can do about it.
Just bear with me. I'll see if we can.
Oops. Just pause in a minute because the view in the room isn't great for people on the screen.
I want to get rid of this. I minimise that and then go back onto the slide. That's better. Oh, no, it's not. That's better.
Right, okay.
Oh, I need to change.
We'll soldier on.
Right, that
I wonder if it's because you set it up as 2 screens. We didn't have time for that faff, did we? Right, sorry about that. In technical interlude, we'll carry on. So yeah, the remit was renewal of life expired signalling equipment, say dating from the 1950s and 60s. Closure of 3 signal boxes, so Basford Hall Junction to the south, SS North or sorting sidings north in the middle of Basford Hall Marshalling Yard, and then Salop Goods Junction at the north end, which is the intersection between the Liverpool Manchester Independent lines and the Salop cord, which takes connects the network to the Shrewsbury lines. Full signalling, resignaling and recontrol. So Siemens were running with that. Full, completely new signalling equipment, signals, track circuits, axle counters at the Basford Hall Junction end, point seating, everything renewed by Siemens, and then recontrol to Manchester Rock or Crew SCC North panel. CRSA scope, we basically did everything that Siemens didn't want to do or weren't best placed to do. So track, overlay and traction bonding, drainage, civils, temporary works for civils and drainage, and then earthing and bonding, environmental topo surveys, and a few subcontract designs related to the drainage installation. So that's an overview of the project. I'm just going to do a little bit on the signalling because that's obviously the main reason why the project existed. Even though it's Siemens, I thought it was worth just setting the scene for the P-way works really with the signalling stuff. So the re-signalling was focused on 3 control areas. So one to the south end, which is Basford Hall control area, which is in yellow, that you can't see under there. The minty green colour, for those of you who aren't colourblind, is SS North signal box area, which is the marshalling yard, and then the red area is Salop Goods box, and that extends reasonably far north onto the Manchester Independence next to the main Manchester lines. Next one, Les. So this is the scheme plan. This is, obviously you can see it's absolutely horrendous around SS North, lots going on, very busy, complex layout. And if we move on to the next slide, Les, that basic elements of that drove some P-way scope. So we had quite a few trap point plane linings that the signalling scheme wanted, basically getting rid of trap points as an asset because the trap point risk assessment said they didn't need them anymore. And then I think area 3A, Les, I think is the main gist of that. I think is to provide point machine controlled S&C instead of existing hand points, basically. So that was what drove the main track scope. Move on to the next one. In terms of what Siemens are installing and designing, so you got some new signal gantry structures there. You can see there's one at SS North. There's a new REB in that picture as well, which is one of 5, I think, that Siemens installed. Photo on the right, you've got another new signal gantry, a new location staging, and then also an OLE structure that we actually shortened as part of the project to enable that signal gantry to go in. So converted a portal to a TTC. Other kind of signalling assets that were installed. So again, there's a new signal gantry close up there, top left, with new TPWS and if you zoom in, see some IRJs and yellow bonds in the distance. We've then got some track circuit leads, all associated with the IRJs, tons of IRJs on this job, UTXs, cable route, axle counters, 2 more REBs at SS North that you can see there opposite each other, and then some disc boxes, bottom right, not that exciting, but if you go down to SS North now, there's loads of them everywhere, taking over the place. So that's a summary of the signalling assets. Right, over to you, Les.
Okay, yes, permanent way then. So I'm just going to show. Right, okay, so just starting off then, it's not just the P-way works, but the whole project was split into 26 key stages. And to table here summarises those stages, spanning between Easter 2022. Stage Annie was the first stage, and this coming weekend we're right over here now at stage Rusty. Oops.
Named after Thomas the Tank Engine characters, by the way. For a bit of fun.
Yeah, stage Rusty. Final commissioning is stage Thomas this Christmas coming. So we're very near at the end of this long haul project now. So if I just zoom out, this is a bit of LiDAR mapping of the whole area. It doesn't quite extend as far as I'd like because it's missed Basford Hall Junction off the left-hand end here, but never mind. So I've just plotted on all the key track interventions that we've done over the last 4 years. So starting at the south end, then Basford Hall Junction, we've replaced 3 of the crossovers on the West Coast main line here for various reasons, which I'll come on to later. So yeah, the 2 crossovers there at the left-hand side, those are T60 layouts, 25 mile an hour. One was a C, transitioned C crossover. The other one was a D. I think 22 Alpha Bravo was the C and 48 Alpha Bravo was the D. And then we've done 51 Alpha Bravo crossover more recently. That was done more for condition than anything else. It was just absolutely falling apart. These crossovers at the south, at the junction here, Basford Hall Junction, take a complete battering by all the freight coming in and out of Basford Hall. So much so that BH51 Alpha Bravos, I believe, I've heard reports that the switches are already worn out and it's not been in service for 6 months. So
Close to facing moves again.
Close to facing moves, yeah. So, I mean, the ideal here was to remodel the junction and put longer crossovers in, which would wear less quickly. So the idea was that it was okay to renew them on a like-for-like footprint under this project scope because we were under the apprehension that HS2 will be coming along 2028 and 2029 and completely remodelling the junction here for South Connection, where HS2 joins onto the West Coast main line. But obviously things changed earlier this year on that, so it's not the case anymore. Right, so stage Thomas, the ones coloured in cyan here, we've got 2 trap recoveries. You can see there on the up through siding, and then one on the down fast independent line. So two traps coming out there. And then what we call area 6B here, where the up independent feeds out onto the up through siding. This was done in 2 stages. So stage Salty earlier this year, we actually renewed the belly and crossing panel on the turnout here, and we put in a new set of traps. And then stage Thomas, we finished the job off by putting the switch panel in and recovering the existing traps, which are at the front of the existing switches. And it was quite a sort of unusual arrangement, this, because the existing turnout's on timber bearers and we've renewed in concrete. So for the past few months, we've had concrete beared belly and crossing panel joining onto a timber beared switch panel. With a temporary staging arrangement of the heel joints. So we actually cut those joints back at stage Thomas and weld in the switches. So moving on, we've got, I should have mentioned actually, the P-Way renewals interventions fall into 4 categories really. We've got renewals for layout changes, so that's the likes of recovering trap switches, recovering redundant assets, that kind of thing. We've got reballasting works, which was to add resilience for the new and extended track circuits. So these sites in blue here around SS North, those were all reballasting sites. due to the fact that we're fitting new or extending existing track circuits along track where they aren't today. And the ballast and in some cases, the condition of the track components wasn't up to having track circuits fitted through them. We were just asking for a track circuit failure straight away if we didn't address some of the existing issues there. So yeah, there was 8 reballasting sites altogether. Some of those reballasting sites, as I'll come on to in a minute, they actually turned into renewals works due to the condition of the track. And then we've got recovery of Coal Siding Road 8, which was a redundant asset, wasn't needed any longer, and part of that works involved converting an existing tandem turnout to a single lead via partial renewals, which was an interesting piece of work. And then Stage Thomas's Christmas again, we've got recovery of another couple of track points here on this sorting sidings lines. A very long reballasting site here, SS North Shunt Neck. We were basically reballasting the whole length of that. That was in very poor condition. And I think the sort of premier renewal for me of the whole piece is South Yard through siding, or as it became known, the Wibbly Wobbly line. So that renewal, it's full renewal from formation up. The main driver for that was to improve the layout and at the same time do a POE conversion, or actually a full renewal on what have been renamed 387 points here. So again, I'll touch on that a bit more in a minute.
We've actually removed the wobble, haven't we? Right.
We have. Somebody said we've taken the wave out of the wob. That those works were completed this August bank holiday just gone. Again, it was 2 stages. The very first job we did, Stage Annie, was the top half, and then, like I say, this August we completed the job. We've reballasted 400 points, set of hand points in here. That was the very first site we used the rail vac on this project. It wasn't intended to be the first site. It was a site we knew we had to reballast, but the rail vac had actually been booked for another job at the time, back in early March. Was it drainage works, John? That was booked for. I remember it was cancelled, and we were facing hefty cancellation charges. So at very short notice, we had to find another suitable site to use it. And when you're reballasting with the rail vac, you do need a rail alignment design, because obviously it's taking all the ballast from under the track, it's affecting the track support zone. You've got to put the alignment back and make sure it's fit for traffic. Fortunately, we did have a full alignment design through this unit, because we'd already got to Form B design stage for the South Yard through siding, so we picked that site, and it all went quite well actually. So that was like the test bed for using the rail vac on this project. And then bottom end of the South Yard through siding, we've got 3 more little reballasting sites where it feeds into South Yard and the connection onto the Nantwich lines. Another Stage Thomas traps recovery here. This is where the down independents merge into one at Saltgoods Junction. A set of traps there that's no longer needed. So yes, SG17 Bravo traps are coming out in December. Right, this was Stage Annie way back in April, Easter 2022. We recovered the remnants of the down Chester line. So all the plain line track was still in there all the way up from Saltgoods Junction down to the North Junction. It wasn't in use because it had actually been disconnected, as you can just see there from the survey data. So we recovered that redundant track, and we also plain line 2 leads, which one's just off the edge of the page again, unfortunately. So those weren't needed. One lead fed into the old redundant engine siding, which goes round the corner and follows the Chester lines up towards Mill Street Bridge, for those that know Crewe. So that was all redundant track. And then the other turnout was where the 2 Chester independents joined. And obviously we were just making it a single Chester, up and down Chester independent line. And then the last piece was this plain line here on the up Manchester. Now we had to take a panel of track out here for drainage to access a catch pit. we couldn't dig down to renew the catch pit with the track in situ, so we had to take a panel of track out, but it was in very poor condition. It's on a very tight curve here. The high rail was absolutely riddled in RCF. The low rail was squashed really badly, so it had severe lipping on the low rail. Some of the sleepers were obsolete, sort of mixed bag type. So we ended up doing quite a lot of intrusive work there just to actually take a panel of track out to put a drainage cap in.
Over canted, wasn't it? Like 90.
It was, yeah, massively over canted, which wasn't helping things as well. And then just to add a bit more spice to the mix, we did discover some underground buried shores between the retaining walls in this area. John said that was hampering the drainage. We had to feed the new drainage pipes through these buried reinforced concrete shores. So that's an overview, a bit of general context. So just flip back to the slide. Go through this again. Okay, so back to Basford Hall Junction then. I've got some pictures here from route view showing the work site. So these crossovers, we had to renew them because the existing POE was HPSS, and it was the only units on the network where HPSS was installed, and the TME was really keen to get rid of it because obviously it needs a different skill set. It complicates maintenance. So we were looking to do originally just a POE conversion on these. However, it wasn't that easy as it turned out, because when we came to inspect these units, they're RT60 S&C. So these are dating from way back 2003. And they're the Balfour Beatty pattern of RT60, because as some of you may know, the RT60 S&C was designed on like a performance specification basis, and there were several suppliers of each that had their own slightly different patterns. These were Balfour Beatty ones, and I think it is a known issue with these. I've read it in a standard somewhere which alludes to this, that they are susceptible to the bearers breaking up under traffic, and this was no exception here. They were in really quite alarming condition, a lot of these bearers. So this gave us a problem, because if we're changing POE and renewing stretch bars and doing anything intrusive to the S&C, we're sort of taking liability for the condition. So we knew we had to do something. So one of the options we looked at was just to renew the switch panel. So we're just going to put up a modern NR60 switch panel, the same equivalent NR60, and join it onto the rest of the RT60 layout. So geometrically that would have worked. We had a look at it. There weren't any issues with that. With bearer spacings were pretty much the same. The geometry was the same. That was the plan. But I think we sort of backed off that approach, because where we're joining into the belly panel, the bearers were just falling apart on some of these point ends, and it was perceived to be too much of a risk. So we actually ended up renewing the whole crossover on these two crossovers. Just see some of the, so that picture on the left there, you can see emergency gauge tie bars. And this is in the West Coast main line on the fast line. Emergency tie bars. And then there was one of the units here at Basford Hall at the time had timber bearers installed between the concrete bearers just to hold the gauge. Those disappeared. That was work being done by another work stream in tandem with us. So I believe those were taken out, and there was resin repairs done with the hold master system to the existing bearers. Right, hopefully this will work. I've got a little bit of footage here, drone footage of the works actually taking place. You can see the work site up there at the top left, a big hole in the West Coast main line. Slideshow back on. Right, so I've got a series of photographs now showing the works that we did. So this is the coal sidings and the recovery of Coal Road 8. This is the south end of the coal sidings, and this is the tandem unit that we had to convert into a single lead. So the way we did this front switch panel here, we plain lined through that, and then we did quite intricate and tricky refurbishments, keeping as much of the existing material as we could to get rid of the crossings and the redundant turnout route. So this is an extract of the design drawing. So the usual colour scheme: red for new, green for existing removed, and blue is existing componentry, which has been adjusted in some way. So mainly the blue here, we were chainsawing the long timbers down once the coal siding, sorry, it's coal siding 9, I keep saying coal siding 8. Well, once coal siding 9 had been recovered and the rails and all the cast material removed, we were able to cut the bearers down to suit the remaining unit, which was this effectively a single lead. So that works went really well. Needs quite a high level of detail on the condition surveys to do this successfully, which fortunately we managed to do. And here's the result. So coal siding 9 has now been removed. You can see there on the left where the ground looks like it's been recently disturbed, and in its place we've got this huge, well, really wide walkway, which must be the best driver's walkway on the network. Quite a bit of money's been spent on that, and the new cable troughing route alongside. Right, this is the South Yard through siding renewal. So on the left is before the works, and on the right is just as the site works were coming to completion this August. So you can see the real poor condition of the existing track there. We've got timber bearers interlaced between existing F27s due to gauge retention problems. It's quite a tight curve, this, a direct reverse curve, lots of obsolete components. The sleepers were a complete mixed bag along here. Swapping from F27s, I think there was some old F10s in there, and then there was timbers, there was absolutely all sorts. And you can just see what a difference it's made on the right there. So we relayed this in composite sleepers with SEN 56 rail and PAN 6 base plates on the left rail, and PAN 6C base plates on the right rail there for the check rails. And you can see where the curve reverses in the distance there. We've got overlapping check rails for the minimum 6 metre requirement, and then the check rail swaps onto the other side. This track, as you can see on the left, it wasn't check railed, and half of it didn't need to be check railed, or didn't strictly need to be check railed, because the radius was more than 200 metres. But the Pre wanted check rails installing here because there are dangerous goods moved around Basford Hall, namely the nuclear flasks. So it was a bit belt and braces to put check rails on around about 250 metre radius. I think this one is the near curve that we're looking at there. Right, it was absolute driving rain when I took these photographs earlier this year, so apologies for the quality of them. But you can see this is quite an odd looking arrangement when you first look at it. This is the new 387 points, and you can see it's concrete bearers, SEN 56 rail, and then we've got 2 timber tow bearers in there with a Raccord switch stand on, which looks a bit odd. This is a temporary arrangement. So from August this year through to this coming weekend, the hand point operation was required because of the existing one with hand points. If we'd have put the POE on there, which is Mark II clamp locks, we'd have needed a points operator on there for a long period of time to wind the point
15
over.
weeks.
15 weeks, yeah. So this was deemed to be a sort of sensible solution to put a temporary set of hand points in. And This rack or switch stand and the timber bearers won't go to waste because we've cunningly devised the program and the design such that we remove these this weekend and they get reused. So the two timber bearers, the switch stand, the point lever boards, that all gets reused on NH87 points at the south end of the coal yard, which slightly weirdly we're converting from HW machine to hand points. That's just to suit the signalling scheme plan. It just seems like a backward step, I know, but there's obviously a good reason for doing that. Not quite sure what it is, but okay. So the route view photo on the left there, I've included this because that is before we renewed 387 points, or as it was known, hand points number 3. You can see the straight through route is the left-hand route leading from the south yard through siding into the coal yard. And as you can see from the photo on the right, which is post our renewals works, we've flipped the hand round so that the through route is the right route, which is it's just so much more logical because the south yard through siding is the main running route, and you want to sort of deviate off into the sidings, not the other way round. So that was the main driver for this renewal. So you can imagine it needed a significant alignment change, which actually you can see the magnitude of the change of the alignment there from the new catch pits. You can see in sort of light blue standing out. Those have been installed on the alignment of the new track. So, you know, they're in the final position whilst the existing track is there in situ, which is, you know, just shows you how much of a slew we've actually had to do in that area. And then this is south yard through side, and again, the photo on the right, you can see the nice straight through alignment on the right-hand route of 387 points now. And the photograph on the left, we've fitted a new lubricator there. We had to lubricate both the new check rails because it's a standards requirement. So the logical place to put that lubricator for the check rails was right in the middle of the reverse where the check rails overlap, because you can do both with one lubricator unit. Just fit two applicators to the same lubricator. And then in terms of the running rails, these are lubricated. There's one each end of south yard through siding. It's a bi-directional line, so you know we've got all bases covered there. The running rails and the check rails are going to get all full lubrication. Oops. Right. Again, this is south yard through siding renewal. So photograph on the left is obviously before we started work, and the photograph on the right is the finished product. So this is at the north end, or the high mileage end of the renewal that we did. This is where it finishes. And this is hand points 2, looking back towards low mileage. You can see there, the photograph on the right, we've actually removed the right-hand check rail off this bullhead turnout, and we've replaced it with an extended check rail to feed into the checked new plain line that we've provided. And there is a gap in that check rail, which you can see there on the right. That's because we've put a forged transition rail in to join the new 1056 plain line to the existing bullhead set of switches. Yeah. Right. This is just a bit on the reballasting sites now. So the reballasting sites, these were driven by a study which Siemens did. They called it a PRIT test. That's panned roll to rail insulation test, and it also measures the ballast resistance. So where those tests were showing that the ballast was in too poor a condition, you know, it was too fouled with fines and contaminated, and it was given a low resistance result. It was a risk to residual voltages when the new track circuits are installed, which, you know, that's significantly increasing the risk of a track circuit failure. So we had to do something about that. And the answer on most of these sites was to reballast. And we did the majority of them with the rail vac. There were 3 sites which turned into full renewals, so conventional renewal Traxcavate sites. This was the Crewe coal sidings neck down here, the up arrivals loop and up arrival number 2. And this was due to poor and obsolete components not being able to withstand the rail vacking and subsequent tamping. So we just basically had to renew them. Also, on the coal sidings neck, the existing radius wasn't actually flatter than it was tighter than 250 meters, which is the limit that the Pre had laid down for having to put check rails in. So as part of that renewal, we were able to realign the track slightly to make it flatter than 250 and avoid putting the check rails on. And the same applied to the up loop as well, arrival loop. Just a little bit on the rail vac here. So it's the Loram rail vac we used. The photograph on the bottom right there, I think that was Basford Hall holding siding after the ballast vac had been through. You can just see the water problems that we're up against in Basford Hall because the track was left swimming in water. And just interesting to note there that that this is the manufacturer's literature. They're saying that it can break through tough materials with 5,000 pounds worth of force. We did actually witness that because on one of the sites in a minute, I think it's the pitching stones that the ballast vac was ripped out, unfortunately.
That was the holding siding as well.
It was the holding siding, yeah. Right, so this is up arrival number 2 siding. On the left is the existing, and the right is post doing the renewal works. The problem with this siding is the existing sleepers were F10s with BJB fastenings. Some had the Pandrol conversions in, the odd ones. It was all in poor condition. They were missing BJB fastenings. Some of them were just sticking up in the air and not actually holding down the rail foot. And just to add a bit more interest, it was mainly welded here, a long length of CWR, but it did have an odd few joints in there, including an old cascaded IRJ that had come in with the cascaded rail. So it was a right mixed bag, which gave us a bit of a headache because we were renewing and then we had to tie back into this non-compliant CWR. So the solution we came up with in the end, it's a suggestion from the Pre. We actually had, we cut in extra adjustment switch and we had overlapping stress transitions. So as long as we had no more than 180 meters of track between adjustment switches, that was deemed to be okay, and we didn't need to stress it, even though it was all welded up. This is another picture, up arrival number 2, looking from the low mileage end towards high mileage. Again, on the left, you can see the condition we were facing beforehand, and then this is the limit of the renewal at the low mileage end. On the right there, you can see the F10s and BJB sleepers transitioning into the new G44s that we've put in. Up arrival loop, that's just typical of the track condition on the left there. So we've got MRC base plates with Mills clips, and they don't seem to be doing much really there. The sleepers, broken backs, just absolutely rotten.
Massive spacing as well.
Yeah, huge spacings, as John's just pointed out. So there's no way we could rail vac through that and then do a subsequent tamp and leave the track in any state fit for reuse, which is why it turned into a full renewal. And then, right, this is the big long SS North shunt neck. So again, on the left, you can see really quite ropey alignment, probably all right for the, line speed of 10 mile an hour for what it's doing. But by the time we'd reballasted this photograph on the right, you can see it's just a massive improvement. I think that's still awaiting its follow-up tamp. It still looks a little bit wibbly wobbly, but it's a damn sight better than it was. Right, this is 400 points. So this is the one that I mentioned we did right early on. This was the first unit that we used the rail vac on. And you can just see the difference there, that the ground, remember this, it was really hard, compacted ash and gravel. There wasn't really much ballast in there. It was just as hard as nails, and the ballast vac just chewed through that, just made an easy meal of it. And you can see the completed reballasting on the right there, and also this has had some POE refurbs done to it. This unit the refurbs comprise fitting electric detection. It still stays as hand points, but it has an electric detection unit fitted both sides. So you can see we've changed the point lever board. The blue one is a new one, and it's had a notch cut out ready to take the BR998 electric detector unit on the left-hand side. You can see the shiny new fixed insulated stretcher bars there as well that have gone on. And then just in the distance, you can see those green marks. That's part of the IRJ works. South Yard again. This is the lines branching off into the South Yard sidings. So before and after. Again, the ground was really, really hard and compacted here. Reballasted through it. Just another one. Right, this is South Yard through siding again, hand points 2 on the right. You can see the plain line renewal, but on the left, this short stretch of track between S and C, that was ballast backed as well. And this is the north end of South Yard through siding. I haven't got an after photograph of that one, unfortunately, but that's what it looked like beforehand. And then it's got 5 o'clock now. Coal sidings neck. So again, left existing and right following the works. I'll start rattling through these now. It's just conscious of time. Yeah, so this one's quite a good one as well. So you can see coal sidings neck and 88 Alpha Bravo crossover before the works on the left, and then again once it's been completed on the right there. This was the full relay in G44's 756 rail, which we did between 2 bullhead units. So we're transitioning back with junction plates at each end on that one. And Basford Hall holding siding. I couldn't get a photograph of this without any stock on because it's always full. It's always got 3 locomotives on it. So it's a very heavily used little siding. And here's this. I mentioned this just a little bit earlier. So this is just after the rail vacking. The holding siding is on the right there. You can see it's actually ripped out some of the pitching stones there, and then you can see the standing water in the excavation. Right, so we did 3 buffer stop refurbishments as well as part of the re-signalling. These buffer stops are cited as our signals, and they need to be brought up to scratch. So on the left there, this is SS North shunt neck buffer stop, and then following our refurbishments on the right. So it's had a new retro reflective buffer beam plate put on, new lights, all the ironworks being brick blasted and painted. It's had bearer replacements, and we've put new IRJs on the to the fronts on the joints here. Front joints, we've fitted IRJs on for, to ensure the insulation. This is coal sidings neck buffer, so there were quite a few timbers replaced on this one, and again the ironworks being treated and painted, new buffer plates and insulated rail joints. And Basford Hall holding siding. Now this buffer was in particularly poor condition. You can see on the left there that right hand front rake is not actually connected to the rail. It was just flapping about, and it was the most ancient buffer I've ever seen. The rail depth here was down to something like 123 millimeters. It's the thinnest piece of rail I've ever seen on the network. And you can see there the buffer beam, the oil marks, the grease marks on the beam. This is because there's always 3 locos on that siding, and it's not quite long enough for the purpose. So the drivers, they ram the locos right up to the buffer, and they only stop when the buffer plates are compressing on it. And it's got that's not a loke behind the buffer. That's a loke cabinet, but it's used for storing the likes of lookout gear and clips and scotches and that sort of thing. It's not really the best place to be putting a storage cabinet. So you can see on the right, we've moved that. You can see it there in the distance. We've moved it a safe distance away outside the buffer overrun risk zone. And we've placed a brand new buffer stop on here, manufactured by Trackwork. That's the heavy duty buffer stop to the REPW design drawing standard.
It's already got oily marks on it as
and
well.
It has already got oily marks on it. So you can see that the practice is continuing with ramming the locos right up to the buffer. Right, the insulated rail joints work stream now. This was a massive piece of work for us. So because of the rebonding that Siemens have done, we've had to do quite a lot of work on IRJs. So installing new IRJs, refurbishing existing ones, remaining where they are, and recovering redundant ones. This is just a small extract of the many scheme plans, not scheme plans, bonding plans. This is the green bonding plan, which shows the recoveries. And this is an example of the red bonding plan, which is all the new IRJs. This is SS North, and you can just see the complexity of it. This one has been annotated such that each IRJ has got its own unique ID. So that's what all the faint blue boxes and numbers are. And then you've got all the bonding arrangements shown as well. So just some examples of IRJs here that we've encountered. You've got 4-hole shock glued, 6-hole shock glued. There's a fair few of those on the West Coast main line that we had to do works to. And bottom right, we've got a 4-hole dry site fitted one. You can see the tags on there. So all the IRJs within the project area, they're all tagged up with the IRJ ID numbers, and there was a colour scheme to these tags. So I think that one was an existing one to remain with the blue tags on. And just some numbers there on the bottom left. So there's a total of 578 IRJs that we considered. Retained, there's about 200 there that we retained. Some of those got refurbished, 37 of them. 207 brand new IRJs to be fitted at new locations. 22 shop glued IRJs, that's new shop glued IRJs, mainly in the West Coast main line, around Basford Hall Junction area, and 136 recoveries. Right, okay, so this is a little bit on track circuit chair protectors, which I'd never heard of before I worked on this job, or colloquially known as Murphy's slippers. And so this is where there's a signalling standard clause which requires 200mm clearance between chairs or base plates where you've got rails of opposite polarity. And this is to reduce the risk of a track circuit failure by a piece of metallic litter, such as a drinks can being wedged in there and short circuiting. Right, okay, so I'll just explain what this is about then. So this is a case study of IRJ T115 alpha at, I think this one was, yeah, SS North. So I've highlighted the IRJ location in question there in yellow on the photograph on the left, and then also on the bonding extract on the bottom right. So you can see here, we've got the switch heels is here, and then we've got rails of opposite polarity. So the track circuit's in this rail, in the belly rail, but in the running rail, you haven't got a track circuit. So there's a risk here that if we breach that 200mm gap between metallic base plates or chairs in this case, there's a risk of a track circuit failure. So these are the locations that we have to fit the Murphy's slippers to until you've got a clear 200mm between the metalwork. So this was quite a task. You really have to think when we're designing all these sites and specifying the Murphy's slippers. It was a real sort of lock yourself in a quiet room somewhere to get your head around it all. This is what the Murphy's slippers look like. So when we started the project, there was only one pattern available, which only fitted and were only approved for BRV base plates. There was nothing for bullhead, and most of the stuff we're up against on Basford Hall is bullhead. So we actually had to have new Murphy's slippers designed and then get them pads approved. And the arrangement we came up with is one pattern of bullhead chair protector to fit L1 and M1 chairs. These chairs being the most common in these tight areas where you've got crossing V legs and switch heels. Usually you have a few L1, M1 chairs because they're more compact than the standard AS1 chairs. We did look at having a different pattern of protector fabricated to go on the AS1 chairs as well, but it was just deemed to be a bridge too far, so we didn't do that. And this is an example of the IRJ siting sketches that we produced to specify all these IRJ works. We did 184 of these siting forms, and you can see on here the right, yeah. Just trying to get the pointer working. There we go. So the nomenclature on here, the red rectangles are where we're specifying the chair protectors, but we've actually labelled up the base plate type to the end of where the 200mm openings is, and these being AS1 chairs, we can't fit the protectors to them, but we've shown them anyway, and we've labelled the type of base plate to explain why we're not going the full length to where the 200mm openings occur, and we've got a derogation on this project to do this, so we're just obliged to fit the protectors to as many chairs as we can, without going mad at it. And yeah, this is just a typical siting form, and like I said, we did 184 of these in total. So the black ones are existing IRJs to be retained, the red ones are new IRJs, and just explained about the track circuit protectors there. We did also do a full detailed schedule to accompany this, and this schedule had every IRJ listed and all the extra details that the construction team needed to know, including the XY coordinates so they could find them on site. So it was a massive piece of work.
And a CAD model as well.
And a CAD model, full, yeah. So that siting form is a snippet from our CAD model dropped into a border on a siting sketch that when you print it out, it gives you a nice handy A3 sketch to use on site. This is a little bit of a rogues gallery, just some of the more challenging IRJ sites we came across. So this is the infamous T185 Bravo. So the photograph on the left, you've got a single slip to the left and a fixed diamond to the right, and this is a continuous check rail going through it, and we were looking to retain an IRJ at this existing location, but you can see from the photograph on the right it wasn't really in fit condition to retain, so you've got a piece of plastic wedged between the check rail there with a zip tie through the bolt holes to try and keep it in place. And we had to try and sort something out for this to make it compliant. So what we ended up doing is reusing the existing rails, but we cropped those flame cut flares off, and we actually dragged. So we cut one bed off here where the joint is, cut the flare off and dragged it up one bed. So you can see where it was with the green, which we could do because then it brings it in line with the check rail on the opposite side. And we spliced in a piece of new rail on the extended wing to the crossing here. So we just cut it back and spliced a new bit of rail in, and then that allowed us to put an IRJ check rail kit on there. The name of the game in this was to do as little work as we could get away with, really, but make ideally a fully compliant result. And now this one, it doesn't look that difficult on face value, but it really did give us a lot of grief. We had quite a few iterations at this one, but this is coal siding's neck where the crossover joins back onto the up independent, and the way we tackled this one was a little bit similar to the one I just mentioned. We ended up taking this piece of rail off. We put a standard length 13-foot bullet check rail on here, and then we cut this rail back. I think we took a bit off that end and dragged it back. So we ended up with the IRJ having a gap in the check rails, because the check rail on this side isn't actually performing a function. It's a check rail on that side that's doing the work. So yeah, we managed to sort of get by with a little bit of work on that one. And then this one, existing installation on the left, we've got a crossing unit on vertical S&C butting straight up to the stock fronts of a bull edge unit. So you can see here AS1 chair inclined at 1 in 20, the rail joining straight on to a BRV base plate, vertical incline. There wasn't any twist in this rail, so it was all a bit of a bodge, and we needed to put IRJs on here. We didn't want to put an IRJ on a forced twist at a joint because you're just asking for the joint to continuously fail. So we actually ended up on this one doing quite a bit of work. We put a new crossing in with a twist forced into the left-hand V rail, and then we also changed the left-hand running rail and put a new twist rail in there as well. And then we've got junction lift IRJ plates. So a lot going on there. And just added this one because these are some deep skirted IRJ plates that we put on. And the S&C refurb, so this is the POE conversions. We did a total of 90 inspections initially for the initial sort of scoping exercise to see what works we needed to do. That was 90 S&C inspections done by our CRSA POA team over a matter of about 3 months, I think it was. We started actually in lockdown, in the first lockdown for COVID. And then following that, we did a bit of a sifting exercise and narrowed that down to 47 units, which actually needed some form of work on them. So we did full TEP 3255 inspections on 47 of the S&C units to specify what refurb works we needed to do. And I've just got one example here, which is 66 Bravo points. So you can see the original installation on the left and then post refurb on the right. So works on this one included quite a bit of grinding of lipping on rails, re-gauging of the switch panel because the gauging was non-compliant. It was beyond the intervention limits in some areas. We've got new Mark II clamp locks on with remote condition monitoring. The back drive has been refurbished and refitted. We've swapped the stretcher bars for tubeless stretcher bars, and we did a couple of bearer replacements on it as well. And you can see it's had a new nameplate there as well. So that's the sort of typical work scope for some of these POE refurbs. And just very quickly now, because I'm conscious of time, we did actually have a look at speed increases through Basford Hall as part of the crew programme. The idea was that we would use the independent lines for diverting passenger traffic during the 8-day blockade in 2028-2029, when crew station layout was ripped out and remodelled for HS2. So we did a lot of work on this. It was only quite moderate speed increases we were looking at. So where the current lines are currently 10 mile an hour from Basford Hall Junction through to SS North, we were looking to increase that to 25, which is the blue on the bottom here. And then at SS North, the speed increase dropped to 20 through to Salop Goods. And then we had a little bit of 30 mile an hour at the Crewe North Junction end. Right, so in terms of refurbs, so we were looking at doing a lot of renewal and refurb work here, partly for the speed increase and partly to make the track fit for passenger traffic. So this is a summary of the S&C scope, which basically we've got 10 refurbs, 10 heavy refurbs, 25 medium refurbs, and 16 full renewals there in terms of S&C units. That's what was proposed. And then in terms of plain line, this is the schematic here. We came up with a colour scheme. Red is high priority and the orange is lower priority. The work scope did include all of those high and low priority works. In the end, that was the plan, to renew pretty much all of the down independent lines through the whole site and patches of the up independents. So the total spec is almost 3.5 miles of track skim dig, 1,260 yards of CWR conversion, 814 yards of re-railing, and almost a mile of additional track quality and design tamping on the track that we weren't proposing to renew. That was to realign to get the speed increase. And that is it. So I'll just hand back over to John to talk a little bit about the drainage before we finish.
Worth saying on diversionary stuff, it didn't actually happen, did it?
No, obviously it didn't happen when
Exciting,
was cancelled earlier this year.
Yeah. I take the mouse and just look. So I'll rattle through these slides on the drainage just to give you a taste of what we did and why we were doing it. So why was a drainage scheme required? It's the first question. So photographs are kind of self-explanatory, I think. So that photograph there was like winter 2022, I think, at SS North. Freightliner shed in the medium distance. 2 independent lines where the Class 66 is sat, running through the middle of that. Electric point operating machines, track circuits, don't like being underwater. And then top right is going under the Shrewsbury intersection line bridge on I think that's the up independent side. That's completely submerged. That was around about the same time. And you can see a few other pictures of the arrival loop area that Les told you about being reballasted earlier. So general long-term drainage problems, which the resealing project wanted to fix to protect their assets. A few other pictures you can see of why we're doing it. So the resealing project is obviously introducing the new funky POE refurb S&C, and then you've got AWS magnets, TPWS, point machines, bonding cables, etc., all of which don't want to be underwater, because there's a history of track circuit failures through the independent lines, which obviously cause a lot of problems for the operators on a weekly basis. So the first thing we needed to do was establish what the existing drainage system is doing. So you always start with record drawings, and really there was only one, which was this one, dating from when the marshalling yard and independent lines went in. So on that you can see Gresty Brook culvert running up the middle across there. Better image of that there. So obviously before the railway was there, that's always been a river, a watercourse for thousands of years probably. Ends up in the River Weaver. And when the railway went in, that kind of valley would have been infilled with made ground, and obviously they culverted it with a brick arch culvert, which then got extended and extended every time the railway footprint kind of widened. Inside Gresty Brook culvert, which we knew to be the outfall for the drainage in the SS North area, the 2 pipes top left are our 2 main outfalls, one coming from the south, one from the north. You can see the state bottom left of manhole 4, which is our main access into there. And people have been in there doing works, climbing down those step irons, obviously harnessed because you wouldn't do it otherwise. And you can see where they are on the record drawing. We did about 2 years worth of surveys, spent a lot of money trying to jet and camera and work out how everything's connected, what the condition is. And it was a real battle because no one basically knew anything about what's happening with any of it. Even the pre didn't know. So that's what we found out. So from the north, you've got 2 runs of drainage that kind of tie together with some odd chambers, B1 and B2, and then into the culvert at the top there. And then you've got everything south of the culvert comes in where that arrow is, just above chamber A. That's the position of the 2 pipes in the previous slide. You can see you've got chambers of all sorts of different styles and really right mishmash. But now we've found them and we've recorded them in Joggis, and we've resurrected the drainage ones to kind of secure it for another 100, 200 years. This is the kind of thing we suffer a lot from blockages in drainage surveys. That's been the kind of main scope for the outfalls. So on the left was what we found on the southern incoming to manhole 4 and Gresty Brook culvert. And you can see there's concrete. I mean, we couldn't explain why you'd end up with concrete down a main pipe, but that's the pipe that we think drains all of the middle of the yard, which is always underwater. So it's like, why is that blocked? But we could never really work that out. But that's gone now. We've dropped a chamber on that blockage and connected it up to our new stuff. So that's improved things around the signal box. This is another one. This is between chamber A and A1 that was on the previous. So this is the main outfall run for everything from the north. So that's what we found. The problem was that was in a drain run that was about 50 metres long, and it was halfway along, and it was under 2 electrified mainline tracks, 5 metres deep. So you're not digging a hole to go and repair that. So we had to do it remotely with like robots and patches and balloons and all sorts of things to inflate and break it out and everything. And then on the right, what we've ended up with, which is a cured in place liner that runs all the way through. So basically the clay pipe is now redundant. That cured in place liner can stand up on its own as a structural pipe. So that's a major win for the project to get that done, especially remotely without having to dig a massive hole and close the railway for 6 months. The overall drainage scheme looks like that. Nice colour-coded diagram with different networks, draining different areas and outfalling into different places. Total length of the system from one end to the other is about 1.5 miles. Network 5, the orange one at the top end, is installed, as is 2A, 1A, and 2. Network 1 and 4 are yet to happen. 3 is also in as well, and that includes 197 metres of the rehabilitation and lining to that outfall. I'm just going to talk very quickly about network 2 because that's kind of one of the most interesting ones. It's a very long network. Got the length somewhere. Yeah, so I think it's on the next slide actually. Yeah. So network 2 is 1.26 kilometres end to end, so a very long network. The problems we had with network 2 were that it led to very deep drainage, and deep drainage versus kind of standard track drainage in a Cessna or 6 foot is a completely different kettle of fish, really, because 6 foot widths are not really wide enough to be able to install deep drainage. And when we say deep, we're talking greater than 2 metres in depth. Because of the length of the network and working to a constant fall and topography, you ended up very deep near the outfall. The outfall was Gresty Brook Culvert, so we were kind of fixed with depth there, and also had to incorporate a few UTXs under the track at compliant depth and run it through an oil separator as well, all of which make things deep. So the preferred drainage team installation method generally for drainage is trench cut and cover, but we had real problems trying to make that work for the deep drainage on network 2. Ground conditions, but kind of sloppy clay with bits of sand and gravel and other kind of made ground, which meant that the trench wanted to collapse all the time, especially with water ingress, very high water table as you've seen from the flooding. So constantly having to pump out the trench as well, and that's not great in a very tight 6 foot or adjacent to track, because the problem you've got installing drainage in those conditions next to a track is your track settles. Track monitoring, you end up constantly worrying about the track geometry going off or the track collapsing or something. It kind of makes, in the time that you've got on a standard weekend, you haven't got time to put that right, as well as install your drainage. So it kind of defeats the object of what you're doing a little bit. Plus the pipes that we were having to install on a very long network, you're talking 600 mil diameter pipes. By the time you get to the outfall, they get increasingly greater in diameter the longer you go along the network from the start. So trying to fit those in with the working space you get in a 6 foot is really, really difficult. We were edging towards having to take track off to install the drainage, which, as Les told you before, when we did the Manchester Independent, that can lead to loads of problems when the track you're taking off is in a very poor state. You end up having to have an argument about putting that poor track back or putting something good back. And there's obviously cost associated with that, which the project didn't want to pay for. So we had to look at a different way delivering that deep drainage, especially where you get to a very constrained situation towards the outfall. So this was the constrained site that we were dealing with. The drainage was coming in from the top of the screen in that wide way where location N16 is. So we had to go past all those load cabinets. We had to go past an OLE portal, a couple of OLE portals, Siemens new overtrack crossing, cable crossing. One of the OLE structures would have been undermined by the drainage because the drainage depth was greater than the bottom of the OLE foundation. So not good, especially when it was like a switch and anchor structure as well. So we had to think outside the box and try and come up with a different way of getting the drainage through there to the outfall, which is where it says ballast handling yard, bottom right. So what we came up with was guided auger boring. So the benefits of that, the installation is trenchless. Probably heard of directional drilling before, which is a smaller version of it. So what you can do is set up pits. So you have a reception pit at the far end, and you have a drive pit at the front end, and you basically drive your pipes through the ground, guided by a laser probe. So it's quite an accurate way of installing things. And that way your pipe routes can cross the track at whatever angle you want, because you can get a derogation for being tighter than 75 degrees, etc. You can be at depth. And that way, rather than having, so greater than 2 meters, with standard drainage, you need to have filter and carrier. So you have the carrier drain at depth, and you have a filter drain at high level, which collects the water, and they meet each other at every catch pit, and the water from the filter goes into the carrier that way. That made it even more complicated to install in 6 foots. So the beauty of this is that the auger boring can just take your carrier drain, whatever route you want, and you can have a separate, completely independent filter drain network, very shallow, 1 meter deep, wherever you like, and you're not having to worry about getting that in because it's not coupled with a very deep carrier pipe. So what we ended up with, which isn't kind of the ideal route that you'd pick if you were starting from scratch, but the auger boring ran on the route with that yellow line there. So we had a drive pit at CP42, a drive pit at 51, and then we sent it out to reception pits at CP50, CP41, which is off the top of the page, and then also connected it to another network 2A on the left-hand side there, and formed the outfall for that as well. So that all has been successfully installed as of week 22 this year, so August. And it went without a hitch, really, surprisingly. The hardest thing was getting the drive pits in, because they were big 3.6 meter diameter precast chambers. There's a few photographs of what we did. So top left there is driving the caissons in. So basically you have the concrete ring with a steel shoe on the bottom, and that cuts into the clay. And as you go down and down, you just keep excavating out, and it forms its own temporary works, basically. So it's quite a safe way of doing it. And the clay crew was actually very amenable to doing that, and they went in really well. The next photo along is one of the auger boring sections that you can see in the photo on the right there. It's kind of a steel driven section that's the same as the cans, is the word I'm looking for. Yeah, so they were the cans, and they get driven and rotate at the same time. They basically excavate out the material and push it back into the drive pit, and then once they're in for the full route, you then push them out by pipe jacking the concrete pipes in behind them. What I should say is that before you do all that, you establish your route first with the probe, which is a lot smaller. That's the laser guided thing. So the probe goes through first, then the cans, and then the pipe jacked concrete pipes at the end. The pipe jacking you can see in the photo in the middle bottom, and on the right there is just one of the precast rings being driven into to the site by an RRV. Next one, so that's the auger boring. That was critical for Network 2 to get to the outfall. the next thing is the oil separator area, and I'll just speed through this. So yeah, for the drainage design, because we're draining sidings, which there's large risk of oil spillage because you've got standing diesel locomotives and stop signals on the main line and stuff like that. So the Environment Agency said that we needed to put a separator in. We ended up with a 12.4 metre long, 3.65 metre diameter separator, which is a big one, but then there's a very large catchment area and a lot of flow going through that. So the works for that, which we are doing right now, if you go down to Basford Hall, you can see that happening at the ballast yard. Is a very large sheet-piled cofferdam, temporary work for that interceptor, which is 17 metres by 6 metres wide and 7 metres deep to get down to the depth of the base, the interceptor, and include working room around it to make pipe connections and things. Groundwater is approximately 4 metres depth, so we also had to install a dewatering system to extract the water and then recharge it a little bit further along the site, which was interesting. One thing to know was the separator tank, it can't support, because it's in the ballast yard, which has got very heavy plant, such as the ones listed there on the next point. We had to design a very robust cover slab for the separator because it can't take any load on its own. You have to transfer the load each side. You've obviously got guys driving plant there, scraping the buckets along the ground all the time without a care in the world. And they've already knocked a few drainage covers off in the past. So we had to design a slab that could take all of that abuse, which ended up quite a thick, fully reinforced slab. And the other thing is the tank also needed to be vented and also have an alarm. So Network Rail Maintenance get informed when it's full and needs emptying. And last slide, so just some photographs of the ballast yard area where the oil separator is going. So you can see kind of the background photograph. That's where Gresty Brook Culvert runs across left to right. Photograph on the right is an example of the chambers we're going to be putting in. That's one we put on Network 1A already, and you can see the interceptor already sat on site waiting to go in there. Just a little bit of a cross section showing what goes on inside the tank, because it's not an empty tank. It's got lots of sections to it that take the water through to take the silt and the oil out progressively, with different access hatches at the top. So yeah, that's the drainage on Basford Hall.
Thanks, John.
Yeah.
Right, okay, that brings us to the end of the presentation from myself and John. So just conscious of time, it's nearly 5:45. So if there's any quick questions from the floor, if you want to put them in the chat box or just unmute and ask us, we'd be happy to try and answer them. Chat box go. Stop sharing. So, did these speed increases occur? So there's a question there. I think we've answered that. No, the speed increases didn't occur because HS2 was cancelled. So yeah, we did a heck of a lot of work on the diversionary and line speed increase over a couple of years, and it was a bit disappointing, but that's just the way it went. So no, nothing happened, and that particular work stream was shelved in the end. Anybody else got any questions they'd like to ask?
Any point seats?
Yeah, Siemens we installed point seating everywhere as well. Yeah.
When we do the EWAC calls for cold weather, we better at rails use crew Basford Hall.
Is it?
Yeah, it's that bit of a hot spot out of the pun for point seating or point failures.
Yeah, and I think we're installing a lot of new, or they're installing a lot of new stuff where there isn't any existing either. So yeah, full coverage, I think. Yeah.
We've got a couple more questions here. So were there any problems with uncharted services and cables? I think that's your bag, John.
In terms of the drainage, yes. Yes, basically every time you dig a hole at Basford Hall, there's always some redundant cable or buried bit of concrete or timber or something that yeah, we spend a lot of time kind of delaying and trying to work out what things are. But all you can really do is just try and work around it. Ask Network Rail what they know. But yeah, lots of problems. So permitted digs were very important.
And another question, is the plan for the signal boxes to remain in place, or are they being demolished after the re-signalling is completed?
I think the plan is for them to be demolished. Yeah, post commissioning, obviously. But I think if you got your eye on one and want it in your back garden or something, now's the time to ask.
And I missed a question there from Stuart Burrows. So there was no value in doing it anyway to say reduce SRTs. And apologies, I'm not sure what an SRT is.
Sectional running.
Oh, the LSI.
The line speed.
In terms of the LSI, yeah.
Must be,
Yeah. Sectional running time.
It was just going to cost. It just
Yeah.
wasn't worth the money that it would cost, was it? For
Yeah,
the gain that you'd get. It was all about running passenger traffic to be able to renew Crewe Station over a long blockade, wasn't it?
I think that the finance for it, a lot of it was going to come from the cost savings on, being able to divert passenger trains rather than stop them altogether and pay compensation to the TOCs. So, that was going to pay a big proportion of those track interventions that we're looking at through Basford Hall.
I think it wouldn't be worth doing if you were just running the services you're running today, would it?
No.
At all. No demand for it.
Were there any existing constraints that led to non-standard design features requiring derogations against standards? Well, there were plenty on the IRJ work stream that I remember, because trying to retrofit IRJs to historic bullhead non-compliant track was a bit of a nightmare, to say the least. So we did the best we could, but there were quite a few instances where we got derogations for the likes of minimum rail lengths between joints and that kind of thing, and for not being able to fit those Murphy's slippers to the full 200mm openings for a couple that spring to mind straight away. On the actual track renewals interventions, it was all fairly compliant generally. We had the peculiar arrangement of overlapping stress transitions on up arrival number 2 that I mentioned, by dropping in extra adjustment switches, because we were tying into non-compliant CWR that we had no chance of stressing compliantly.
That's probably it. We had some drainage non-compliances derogations as well for shallow UTXs. I think there was a shallow cable UTX derogation as well for the pumping station on Network 4 that hasn't gone in yet. Yeah, it was probably 90% IRJ derogations, I think.
Right, okay, I think we'd best wrap up there, considering the time. So thanks very much, everybody online, for dialing in. I hope it's been of value. Hope you've enjoyed the presentation. And yeah, like I say, thanks for showing interest and joining the meeting. Thanks. So yeah, it's okay. That brings the meeting to a close. I've got no other news to announce. We'll have to keep you posted by the PWI events page on future talks next year. Okay, thank you.
Thanks, Les.
Cheers, Les. Thanks, John.
Thank you.
Thank you both.
Thanks.